Dr. Tom Albright's passion for geography began when he realized that, whether in a car, a train, or a plane, he was definitely a window seat guy. And when he learned that he could use satellite imagery to monitor and measure things, remote sensing, all over the world, he knew he wanted to make geography his profession. Tom earned his bachelor's in geography and cartography at the University of Wisconsin-Madison in 1993. He soon headed to the University of California, Santa Barbara, lured as much by the beaches as by the prospect of working on a NASA snow and ice remote sensing project. After completing his master's in geography at UCSB in 1997, he worked for the United States Geological Survey on collaborative remote sensing projects with scientists and technicians in Africa, Latin America, and China. Along the way, he got the bug to study landscape ecology back at UW-Madison and completed his PhD in integrative biology in 2008. Tom has been proud to call Reno, Nevada his home since 2010, when he relocated to join the faculty at the University of Nevada, Reno. Tom's research and teaching at UNR focus on the interplay of weather and climate with ecosystems and environmental sustainability, examining topics as varied as migratory birds in Central America, rare endemic plant species in the Great Basin, and the urban heat island in Las Vegas and Reno. Most of this work is supported by spatial analysis and satellite remote sensing data. His work has taken him to 18 different countries, most recently as a Fulbright visiting professor at the National Agrarian University at Managua, Nicaragua. Since 2023, he has been serving as the Nevada State Climatologist on an interim basis, where he enjoys sharing information and answering questions about Nevada's weather and climate. Please welcome Dr. Tom Albright.
Thank you. I think I'm done now. That was long enough, right? I mean, that was good. So I got to drive here from, I should probably stay put, maybe make it easier. Yeah, I got to drive here from Fernley today. I stopped at Fernley on the way and hung out with the good people at the Lyon County Library there. They let me use their space for 3 hours so that I could do a Zoom meeting to be on someone's defense committee looking at rangeland management. So it's really interesting being in academia. You get pulled into different committees on all kinds of different things, and you learn little bits and pieces about all kinds of stuff. So it's fun stuff. I like the raise your hand thing. I'm going to do a little bit more of that if I may. I just like to get a sense for like where people are at, the audience-wise. Like, how many of you, for example, would say you're involved in education, either as a student or a learner in some way? Okay. How many of you are affiliated with the Navy, military contractors, military families? Okay, great. How many of you live in more in farming and ranching territory, would you say? Okay. How many of you are raising your hands multiple times here? How many of you live in town? Okay. Let's see, anyone else want to share anything random about where you're at? I just think it's interesting. All right, let's see. Okay, I like to do a little trick I learned a while ago is do your thanks up front so you don't forget them. So thank you for coming here. It is a gorgeous night. Sort of question why we're inside, but hopefully everyone had a chance to spend some time outside. It's such a gorgeous place and such a gorgeous night. Thanks for the chance to be here, and I just want to acknowledge some people whose stuff I integrated and folded into the talk. Laurel Saito from the Nevada Nature Conservancy and Justin Huntington, who's another remote sensing scientist at the Desert Research Institute in Reno. Let's see. All right, so here's a little roadmap for what I wanted to go over today. I kind of thought it would be neat to talk about to talk about like how Nevada's springs are and Nevada weather kind of is, and then the double entendre between like the hydrologic features springs and also the meteorologic springs. So we'll try to get into both of those things. And I'll kind of trace a little bit of a path about like what's our climate like and why is it that way, getting into the variability that we have on an annual scale that we might call weather. Talking specifically about snowpack because it's so interesting and such a big deal for us. And then bringing it into the hydrologic springs and some of the things going on with them, how climate influences them, how some of other pressures that they're facing right now, which maybe you've already had a little exposure to in the previous talks, I'm not sure. But let's see how it goes. And if you have any questions along the way, don't feel you need to wait to the end. I think we can keep it pretty informal here. All right. So I'm going to quote my daughter. Why are you like this? We've probably experienced that in Nevada since we do have pretty impressive weather, I would say. But before we talk about why our weather is the way it is, let's just talk about some of the features of the weather and climate of the Silver State. So first of all, one thing I think is kind of interesting, if you look at the colors, can you see any states that have a bigger color range than Nevada? Maybe Utah gets pretty close. California, definitely. Yeah, California is a very varied state. But we're one of the most varied states in the country in terms of the kinds of temperatures that we experience across our geography. So I think that's kind of cool. We get warm and cold. Okay. Yeah, also, over time, we can have some pretty cold winters, especially in some parts of the state, and we can have some pretty hot summers. And the same place can actually swing pretty far in both directions of temperature. So summertime highs above 100 are common in large parts of the state, and freezing temperatures are also very common. It's a pretty extreme variation. I'd say if you want to get more extreme, you could find spots more in like central continental Canada, Russia is some of the most extreme, the Siberia, where they have huge temperature swings. But we do a pretty good job at experiencing a big range of temperature. I don't think I'm telling anyone something you don't already know when I say that we're a dry state. It's not just a myth, it's not just hype. We are legit pretty dry. But there's going to be some interesting things about the way we interact with water that are going to modify this and allow us to, for example, have a prosperous place here in Fallon in the middle of the high desert. Also, pretty dry in the aridity sense. And that's actually pretty important because our atmosphere turns out to be really thirsty. And that's something we're keeping our eye on. Okay? Also, not shocking anyone here, a lot of sunshine, right? It's funny, there's a bunch of places that claim to be the sunshine state. Obviously, I think people know Florida is a sunshine state. Not super sunny, and they have a lot of They have a lot of thunderstorms, right? A lot of electrical storms there. South Dakota also bills itself as I think a sunshine state or something like that. I lived there for a while. Has anyone heard that before? Yeah. But I guess parts of Arizona, New Mexico, Southern California get a little sunnier, but we're pretty sunny. All right, so the how and maps, as much as I should have warned you, there are going to be a lot of maps. As much as I love looking at maps, it's interesting to see where things are and how they vary. I'm immediately drawn to questions of well, why? Why is that, So let's take a look at that. And as my kid said, why are you like this? All right, before I share my list, I want to hear your list. Have you any ideas why our weather and climate are the way they are?
Sierra Nevada.
Sierra Nevada mountains, big, that's redundant. But Sierra Nevada, a mountain range, big factor. What else we got?
The basin and range. We have so many mountains that the storms have fun jumping over.
Okay, yeah, basin and range. So not only do we have that big mountain range to the west, we also have a whole bunch of ranges, mostly north-south, here in the state.
High altitude.
Yeah, we got some altitude for sure. Yeah, we are about 4,000 here. Mm-hmm. Yep, and Reno's maybe 600 feet higher or so, depending on where you measure it. Okay. What else we got?
evaporation.
Yeah, yep.
Very dry.
Dry, yep. And we could get into questions of why. Let's see, so we got some of the elevation thing as part of it. You know what, you already did half my list. So yeah, one more.
One that strikes me is that since we were once an inland sea, there was no place for that water to escape. Everything just evaporated. So we've got so many salts and other kinds of minerals that make it hard for plants to grow. That's going to add to the heat element. I don't know. It's just a kind of theory.
Yeah. We have like playas, right? Where we have, well, some of them are actively, regularly filling up with water, not filling up, but getting some water in them and then evaporating again. Some of them have been dry for a pretty long time. And, there's a really interesting paleo history. A piece that I kind of left out of the talk just so we weren't here for 2 or 3 hours, but yeah, that's a really, I think we can weave that into the story too. All right, so let's see what my list is. I think you'll see there's some overlap with what you have. Although I started really, really basic. First, I think most of us we're not at the equator, right? We wouldn't be getting freezing temperatures if we were at the equator. But where we are, our latitude is a pretty important piece of it. And I will start with that and just talk about some notions of that. Another one is that we are pretty big, right? So let's go, we'll take a look at each of these. So I think it's really interesting. It might seem kind of basic, but it's actually more kind of nuanced and interesting than I think most people give it credit. Like, have you ever thought about why higher latitude places have cooler temperatures? Yeah, the sun's lower. Okay, well then you might say, well, what does that matter? I'm going to sneak up ahead really quick. I'll come back to this. Right? Has anyone seen something like this? You ever done the flashlight trick? I do this in the classroom sometimes. You shine a flashlight, and if you're shining it perpendicular on a surface, it's a nice circle and it's pretty dense, right? And you take that sheet of paper and you alter it 45 degrees. Now that same circle is spread out over a larger area. We didn't take away any of those photons. They're all there. They're just divided over a larger area. And that's how I usually explain this direct effect. If the sun's closer to being overhead, the sun's rays are more intense, and they're delivering energy at a more intense rate. And if they're more oblique like this, it's less intense. We also have the fact that this is traveling through a little bit more atmosphere to get there, because it's at an angle, so it has to go a little bit through more stuff that we have in the atmosphere. And then there's another big one that you can't see on this. Maybe you can tease apart on this. What's the other thing about the changes over the year from winter to summer? Not just how high the sun is, but
How close to the earth it is.
The tilt of the earth.
those are going on too.
Day length.
Yeah, day length, right? It's like so obvious that we sometimes just forget about it. And that actually can add up too, because you have more time to be accumulating that solar radiation. So there's a few factors that come together and make it warm. We receive more radiation right around the solstice, the June solstice. Did anyone know when we get our hottest temperatures here in Nevada?
Office.
Yeah, it's a little bit of a lag. Yeah, a little bit of a lag, probably like late July into early August. And that's because it takes a while for the earth to kind of, the land surface and water that you might have, soil moisture to heat up, and it lags. An interesting thing, someone mentioned how near and far we are to the sun. That actually varies too. And in fact, a lot of people, if you ask them, they'll say that that's the explanation for the seasons, right? That it's hot in the summer because we're closer to the sun, and it's cold in the winter because we're farther from the sun. There's a couple problems with that though. Have you never heard of the southern hemisphere? You know what season it is they're entering right now in Buenos Aires and in Canberra? Yeah, they're entering fall. They're approaching their winter time. So that's one reason it doesn't work. The other thing is that, does anyone know when we're closest to the sun, the planet?
December. No.
Yeah, it's close. Yeah. We're actually out of sync. We're actually a little bit closer to the sun, during our winter, right? And that actually matters. Over the paleo thing, like that's one of the reasons that the cycles and the variations in that are one of the reasons that we've experienced sort of ice age and big glacial advances in the past. All right, so, but going back to Nevada, we're at about 40 degrees or so, depending on where in the state we are. So we experience a pretty big range of solar elevations. I think I actually made this. This was actually pretty tailored for Nevada, the altitude or the latitude that's trying to represent. It just shows you where the sun's rising, where it's setting, and how high it gets in the sky, and how long it implies how long the day length is. So it turns out that the farther you are, the closer you are to the poles in general, the bigger your swings are between summer and winter. So if you live in the equator, you might get some things going on with when your rainy season is, when your dry season is, but the sun's going to be pretty high all year round, and you don't get very big variations like we do. All right. Other cool stuff, also having to do with the tilt of the Earth and the varying sun angles. There's some really, really big circulation features that redistribute moisture and energy. And you've probably heard of some of these, right? Probably heard of the jet stream, right? Jet stream is ultimately driven by this. Maybe one that's a little bit less famous, but maybe even more important, the Intertropical Convergence Zone. This is a band where we tend to have cloudier conditions and afternoon rain. It's kind of a place of moisture along the equator. And then we get fun stuff here, subtropical highs. Does anyone know what kind of feature you would expect if you have a subtropical high? You're going to be a rainforest, or you're going to be a desert? Yeah. That's one of the big driving factors that produces the global deserts. It's more visible in Africa and Asia because the continents are bigger. South America is a little bit skinny and it doesn't really develop the deserts in quite the same way, but there's little hints of it down here in parts of Patagonia and the Atacama Desert here. But in our case, we have some influence of that. The subtropical high gets close enough to influence us, but something else is going to really help make us dry. We'll come back to that. One thing this isn't showing is this is shifting around, right? As summer progresses in the northern hemisphere, this convergence zone is going to wind its way up here and probably kind of be right around here by July or so, and then it'll shift back down, right? And all the other bands will move around a little bit too. Speaking of movements, has anyone ever heard of let's see, talk about the jet stream. How about ridges? You ever hear about a ridge and a trough, right? On the newscast, they sometimes talk about those. It's, you might not notice that stuff, you might notice it, depends on which newscast you're watching. But a big feature that drives a lot of our weather in the winter time, especially, is that the jet stream is expanding and comes farther south to influence us. And a lot of our winter is determined by whether we're either on this side of it, where it's cold, on this side of it, where it's warm, and on this side where it's windy and stuff is moving through, right? That's a big, you go a long way of explaining what's happening with Nevada weather by where this jet stream is positioned relative to us in the wintertime. So that's another big feature. In fact, it's such a big feature that we, in the West Coast, this mostly shows California, and Nevada shows that it's less than 2 inches all the time, but let's just use our imagination here. You can see that in February, that's when California, all the way down to parts of Baja California, that's when they get their rain, basically, right? In the wintertime, and they can go a few months without rain in Los Angeles once you hit about April or May. Little bits in the mountains there. And you can't see it on Nevada, but we do tend to get the bulk of our precipitation coinciding with our winter season. And it's not like we don't get rain in the summertime, but we certainly get more precipitation in the winter season and parts of the shoulder seasons. And that's because the movements of these jet streams and the positioning of airflow and everything like that. So latitude, covered a few of these things. It influences our temperature by the intensity of the solar radiation, the day length, the fact that we have seasonal variation. These things vary throughout the calendar. And they also influence our precipitation by influencing when we have high and low pressure bands and the directions of our prevailing winds. We don't really talk about that, but I think most of us have experienced where the wind usually comes from, right? Usually comes from California. And that's actually a big deal. I'll show you one more bit on that too. Oops. All right, train wreck. I think I had either I deleted it. If I've deleted it, then I apologize and I'll just tell you what it was, but I'll go through my slides to see if I just misplaced it. The other thing I want to talk about is we are in fact a big state. Pretty big latitude range, and also a fairly big elevation range. The elevation of the Colorado River down here, down by like Needles and Laughlin and places like that. What do you think that's about? About 2,000, I think? Yeah, something like that. Yeah, up to, you know, we don't have 14 Earth, but we have places over 10,000. So a pretty big range in elevation as well as latitude. I'm always surprised, like, how far Nevada extends south of Las Vegas, right? I kind of think like you're kind of done at Las Vegas, but no, there's more. Pretty cool. Two places, I think people recognize that. Yep, oh man, too good, yeah, that's garbage, you can pronounce it.
I live there in the summer.
Oh, cool, yeah, it's a place I haven't made it to yet, but closest I've been is Jackpot. So that's garbage, two pretty different places, I think you could say, pretty confidently. These are different kinds of places. And this is a way that I like to look at kind of, if I had one graph to talk about the climate, of a place, I'm going to use this. And it's a little too small to read, so I've zoomed in. This, I believe, is Las Vegas. You got to be a little careful. Wait a second. Double check. Oh, yeah. This is Las Vegas. And it is showing, there's a lot of information in this. They're pretty fun. It's showing the average high and average low temperature, and then the average mean temperature as you go through the year. Right? So you can see like really obvious things like it's hottest in July and August in Las Vegas. And you can also see how cold they get. And this is the temperature in Fahrenheit. You can see that they don't really freeze very much in Las Vegas. So we did get snow this last year a little bit, a couple flurries. And this is kind of fun. This is showing the precipitation, but you gotta be careful. It's not that it gets, more and more precipitation as you go to December and then it drops back to nothing. It's accumulating it throughout the whole year. So that's kind of fun because you can look at things like where the steepest rise is. That's when it's accumulating it at a fast rate. It's a little bit flat here, so this is a time when we don't get that much precipitation. And then it picks up in July, which is something we don't see here. Does anyone know what this phenomenon is?
Comes up through Baja.
Yeah. We call it the North American monsoon, yeah. So parts of Nevada experience a little bit of a monsoon influence, which is just this phenomenon of the way the storms track up. And that picks up in late kind of July or so. And that's usually really welcome because people are pretty glad to have the water and maybe a little bit of cool down if they're lucky to come along with that. We don't really get much of an influence. You get more as you go towards the east and towards the south in the state. And this is garbage. So be careful here. It looks really similar, but they changed the axis label. So it's a lot colder, and you can see that the temperatures are averaging below freezing in the winter, which if you've been to garbage in the winter, it shouldn't surprise you. And you can also see this accumulation. It's a little bit more even, but it's a little steeper in the wintertime. And a little steeper in the shoulder seasons too. So pretty big range, big state, lots of variation. Yes, I do have this. I didn't forget to include this. I wanted to talk about how the proximity to the Pacific Ocean influences us, but how that's moderated and changed by being a little bit inland and having those mountain ranges. So I skipped the thing about the California current, but if any of you ever dipped your toe in the Pacific and then gone to the same place in the East Coast, yeah, it's a little cooler. We have our ocean currents are flowing from Alaska, so the Pacific is a cooler ocean at the coast than the Atlantic is in general. But this year, I think a few years ago, I feel like people didn't talk about these as much, but now they're starting to talk about them a lot more. Has anyone heard of the Pineapple Express and atmospheric rivers? I love those terms. I don't know which one I like better. They're both kind of fun. They both for me convey something about it that's kind of useful. Maybe atmospheric river is a little bit more serious and Pineapple Express is a little more fun, but it's really not an exaggeration to say that it's like a river in the atmosphere because it's flowing fast, it's delivering a lot of moisture, and this satellite imagery is showing it's measuring atmospheric moisture or water vapor, and the colors reinforce how much of it there is, and you can see how kind of narrow it gets, and it's like lashing the coast. And that's what was responsible for the huge accumulations of snow we had this winter, this March. You know, I got a lot of media inquiries in February saying, are you worried? Are you worried? What's going to happen? And it's El Nino. Aren't we supposed to be getting some more rain and more snow? And I said, you know, it's Nevada. You can't really be too sure. And the El Nino doesn't really tell us that much about how much precipitation we're going to get. We just kind of have to wait and see. And the difference, it always boils down to, it's usually just one or two storms that make the difference between a below average and an above average winter. That's really what it boils down to here. A couple big storms can make all the difference for us. And that's what we saw this year. March came through for us and took us from a below average winter to basically an average to slightly above average winter. So, thanks to these atmospheric rivers. Now the other thing, so that's the proximity to the Pacific. Now the thing that's going to attenuate is good old geography, but also the mountains. Someone mentioned that right away. And this is fun. I love teaching this. I'll actually spend a whole lecture talking about this phenomenon. I have students do the math and figure things out. But in it, the way I like to explain it to them, the way to think about it is, the atmosphere is like a sponge, okay? And it's got some moisture in it. You know how you have the sponge and it's got a little bit of moisture in it, you squeeze it, nothing comes out, right? Squeeze it some more and it starts to come out, okay? Think about a sponge as like half full. And as that sponge goes up in elevation, it's like the atmosphere is squeezing it, because the atmosphere doesn't have as much ability to hold water vapor as it gets lower and lower pressure, okay, and colder temperatures. And so it's like squeezing that sponge. And it squeezes the moisture out of that sponge. And then when it hits the crest, it starts to kind of unsqueeze it, right? Well, when you unsqueeze the sponge, is it still dripping? Not really. You've squeezed it out. That sponge doesn't have as much moisture as it had in the past. You've gotten rid of some of that moisture. Now the sponge analogy kind of breaks down when it gets to temperature, because the other thing going on is dry air, as it sinks, warms up at a faster rate, okay? And so the air at a corresponding altitude on the leeward side, the back side of the mountain, the Nevada side, the east side, is going to be a little bit, not only drier, but a little bit warmer than the corresponding latitude on the west side. Has anyone noticed when you drive in, if you make it this way very often, you go over Downer Pass, you head towards Sacramento, you're coming down the mountains, like where do you like see like piney looking, conifer forests? Like it goes all the way down, almost to like Placerville, and almost all the way down to Sacramento, and then you start seeing the planted palm trees and stuff. But if you were going to go to the Nevada side, you would not be seeing forests at those latitudes, right? That's because we're drier and a little bit warmer. It's a little complicated because there's also some like circulation issues in there that don't always make us warmer for a corresponding latitude, but we're definitely drier. So this is the rain shadow effect. It's squeezing out a lot of the moisture and, frankly, denying a lot of that moisture to Nevada because of that big kind of wall of topography. So that's another really big influence on our climate. Right. And then more locally, we have a bunch of mountains, valleys, and ranges, so they can each have their own little rain shadow effects, and certainly elevation and temperature comes into play. But I think it's really interesting just to see how the temperature varies. This is a sort of a topographic map. It's sort of showing some slopes, and the sun would be coming from down here. And what's interesting, what people don't always realize is keep your eye on point 1. That's this one right here. And this is point 3, it's at the top. So most of us would say, well, at the top of the mountain, it's gonna be colder, right? Who agrees with that? Okay. What about break of day, winter morning? What do you think is gonna be colder?
The valley.
The valley, okay, so I think some of us have lived experiences in this. Maybe just from camping, or you've experienced this yourself. Yeah, it's sort of counterintuitive, but it's something called cold air drainage. And at night, if the conditions are still, you're not getting new radiation from the sun, so that cold air will just slough down because it's denser and accumulate in the valley. So if you want a warm camping spot on a night that's kind of a crisp night, maybe don't go to the valley. Maybe camp up a little bit, and you'll spare yourself some of those coldest temperatures. So there's a lot of really cool, interesting stuff that goes on with topography and our temperatures, in addition to moisture, which we already saw. So this stuff's super interesting. A big challenge of working in Nevada is it's so big, and some of the stuff's pretty remote. You don't have access to power, and all kinds of stuff. Communications are a challenge. So there was a big project about 15 years ago to put in some instrumentation. This is right by Great Basin National Park. Anyone been over there before? Great spot. There's some towers there that some colleagues put up, and they're monitoring temperature, they're monitoring moisture, wind. They also have soil moisture sensors. They're monitoring everything down to how the diameter of tree trunks actually changes in ways that we can measure at the scale of the day based on how much moisture they're getting. So really cool stuff just to better understand how the mountains are affecting our weather and climate and the ecosystems that make their home there. All right, let's get that one. All right. Whew. Is that enough about like what explains our weather? Come away with a little, hopefully, new appreciation of that. We're going to pivot a little bit and talk specifically about snowpack and groundwater. But before I do, just want to invite any questions while I take a sip of water. Yeah.
They were saying when we stay in Arizona that one of the reasons why Phoenix is getting so hot is that it's because of all the cement and all the buildings. Is that why Vegas is starting to get the same heat at the same time?
Yeah, that's a good question. In fact, it's really timely. I'm really happy to announce that we just, the State Climate Office led an effort with Washoe County, Reno, and Sparks to get a federal program to measure, get community volunteers to drive around and in some cases bike around and measure our temperatures all throughout the city, because we're trying to measure just that. It's called the urban heat island effect, and it's absolutely a real and significant thing, and it does have to do with like how much pavement there is and concrete, whether there's vegetation or not. It can even have to do with how much irrigation and evaporation there is, because like in the desert cities, we actually have more trees sometimes, and we have more humidity than the surrounding areas. So sometimes we have hot temperatures, especially at night in our urban areas, partially because of those factors. But yeah, the urban heat island is very much a real thing, and it's kind of a public health problem because a lot of people get into trouble with the heat and they don't even realize it. questions? All right. So I love snow. It was a huge part of my childhood. I love getting out there. This is just kind of in South Reno, overlooking downtown. It's really wonderful that you can just hike out in that and kind of get away. So I think snow is a big deal for us for a few reasons. First of all, it's the source of most of our water in the state. So most of our runoff in Nevada starts out as snow. I don't have a single number for the state, but it's well over 50%. And that number is pretty close, pretty true for most of the western states. It's probably a little bit higher in Nevada. Another really cool thing about it is that, have you ever thought about how fortunate it is that the snowpack stays in there in the winter when we don't really need that much water, right? And then it delivers it right when we're growing stuff? Like, isn't that awesome? That's something that we like to, the fancy name we put to that is an ecosystem service, right? When the natural world does things that are good for us, that we like, that are handy. And that's a really, really, like if we were to put a dollar value on that, it would be astronomical. The fact that our mountains hold that water for us, help it accumulate, store it, and then mostly deliver it when we need it. So that's a pretty cool thing about snow. And the other thing is, I like snow because I like to get out and ski and walk around. I always try to have a dog picture in my, I was happy to put the dogs, that's Diego. And these are some students doing a field course, and that's a snow pit that they dug. It is that big. Get some big snowfall out there. So snow is really cool for a lot of reasons, and it's also worth reminding that the very name of the state means snow. So that's my little pitch for snowfall. Another interesting thing about Nevada is that our major cities and a good portion of some of our agricultural areas, when you consider Walker and Truckee and Carson in particular, we get a lot of our moisture for cities as well as for agriculture. It comes from out of state, right? Most of it's coming from even here in Fallon, right? The Newlands project, that water mostly originally came as snowfall that fell on California. And hold your California jokes. I know we like to pick on them. And then if you go down to Las Vegas, a lot of their water is coming from the upper Colorado Basin. And I'm happy to say, as a state climatologist, I keep my eye on those states too. I'm happy to say that both of those areas have had a pretty good year. It's when you get up into the Northwest, Montana, the Cascades, they are having problems with snowfall this year, but we're doing okay. All right, so the other thing about snow, though, that I want to mention is and this gets us back to our springs, it is highly variable. I've already alluded to this a little bit, but let's take a look at it. These are fun figures. You can go and there's a URL down here, USDA. There's a couple different places you can access this, but this is showing a particular SNOTEL site. It's a special climate monitoring station that's specialized for monitoring snow. And that's really important for hydrology, and it's like our eyes on what's going to happen in the next season. And this is the Upper Humboldt, right? So our nice inland water system in northern Nevada. And you can see just a huge variation since we've instrumented this site in how much snow that you have. You can see it accumulating and then going away. That's the driest year on record, and then this is the wettest year on record. And then this green dot is the average max. So it tells us what time of year we typically have our max and how much snow water equivalent. If you melted all that snow, how much water would it be? So, you look at something like this and it really makes you realize it's all over the map, how much water there could be in our snowpacks. Unfortunately, we tend to be like, they had a good year there too, not just the Sierra. So this is places like the Rubies. They had a pretty good year. I suspect they're probably like around here, a little bit above average. Drought. I can't believe I made it almost half an hour into this talk, and this is the first time I've mentioned the D word. I'm actually really happy because when I took this job, we were in the middle of a drought, and it was actually just starting to get better. But if we looked at March 31st in 2022 and compared it to March 31st in 2023, it is night and day, right? What these numbers represent, let me try to make sure I'm looking at the right things here. Yeah, they're the percent of normal, right? So that those basins have in terms of water. So we're seeing numbers like, 30, 40% sometimes. Okay, here's some in the 30s. Just a small fraction of the normal amounts. And then about a year ago, right? We're not quite as high now, but we're doing okay. We were sometimes several times higher than normal. Yeah. So that really, really helped us put an end to that big drought that had been hanging over our heads for a few years. So this really gets right to the theme of springs. They're kind of all over the map, right? A lot of the snow is falling in spring, and it's affecting our spring weather, and it's affecting our spring water availability. Some interesting things about this snowpack. Why does it vary so much, right? Well, first of all, are we getting the storms, right? Are those pineapple expresses coming the way we expect them as much as they want? And it's just, kind of a flip of a coin. You don't really know what you're going to get, and it's pretty hard to predict. Then you have the question of, is that precipitation falling as snow, or is it coming as rain? Right? And that's a big deal, like for recreation, for road travel. It also is a big deal for what happens to that once it lands on the ground. If it's snow, it's kind of nice and cooperative, and it stays in place and does the things we want it to. If it's rain in the middle of the winter, it can create some flashy, it can help melt the snowpack that's already there, and it can create some flooding conditions, so it can cause some headaches. And this is a tricky problem. The problem is so tricky that we don't even really have a good way with all of our technology of knowing where that rain snow line is, right? So where it is on any given day at any given moment, we actually rely on what we call citizen science observers, people that want to just contribute, and they get a little app and they can say, oh, it's liquid, or oh, it's snow. And that's one of the ways that we use to try to keep track of it. So that's a big piece of the puzzle. Is it snow or is it rain? How fast it melts, right? So that's going to have to do with how temperatures, but actually, especially when you get towards this time of year, more important than the temperature is how strong that sun is. And that how it melts out the snowpack is a really important question. You can be above average in snowpack and still be below average in runoff, depending on how it melts and what happens. And one of the enemies to that is something called sublimation, which is, you ever heard that term? Ooh, wow, this is a very weather savvy group. All right, you want to shout it out? Yeah, so I'm going directly to gas, evaporating directly from frozen state, which means we're not going to get a lot of it running off, right? All right, so that's a big deal. Related to that, has anyone ever seen really, really dirty snow? This is a big factor for us because actually tying back to the playas, right? We have lots of dust sources, and if the conditions are right, we can get storms, we can get events, we can get things that push that dust in the air, and when it gets on the snow, it's going to make, what color is snow?
White.
Right, not a trick question, not a trick question at all. It's white, it's one of the whitest things there is. And so if you have something that's reflecting maybe 95, 96% of the incoming solar radiation, and you put something in it that even just absorbs a few percent, let's say it absorbs 5 additional percent. Well, you went from 95 to 90%, you just doubled how much energy that snowpack is absorbing, right? That little change makes a big deal of how fast things are evaporating, sublimating, and melting and running off. And that can affect how much runoff we get out of that. And another fun thing is it's not just dust, it can also be snow algae. It's another thing that can affect the albedo or the brightness of the snow. So there's all kinds of interesting questions with snow too.
I have a question about the sublimation, if I may.
Yes, please.
Because usually I like to ask questions, so here.
Yes, thank you.
So when you do have a higher level of sublimation, and in my experience is because there's like a strong wind, does that mean that downwind they're going to end up getting more moisture because it's accumulating up into the air, or what's the effect of the sublimation?
One thing I learned is that it's okay to say I don't know. And I think that's a really good question. I don't know. I mean, at some level, if there's more water vapor, it's gonna go down. It's gonna go someplace. Just like have you heard of cloud seeding? That they have a program to do that. Some people are concerned that enhancing snowfall locally will dry out further downwind.
Yeah.
And so that's, maybe same kind of idea. If there's extra sublimation, there's extra vapor available. But I don't know.
Why, say you had a big dust storm and came across, covered a thin layer on this as if it was a volcano. Why isn't that an insulation and to keep the snow from melting?
Ooh, interesting question. Yeah. So if you had enough of it, if it was thick enough, you would have like kind of a cap over the snow, and it could actually slow down the rate. It would have to be really thick because before it gets there, those dust particles are they're intimately mixed in with the snow, and it's going to make it darker. But yeah, you're right. Theoretically, if you did it thick enough, and it would have to be really thick, you could probably insulate it. Like a rock glacier, if anyone's ever heard of one of those, where you have rocks over a glacier that keep a glacier from melting. Really cool questions. All right. Finally getting to springs. All right, so now I'm getting a little bit out of my element. I am not an expert on springs. I know a few things. I've spent some time in them. You probably actually are more experts now because some of you have been to 2 or 3 of these talks already. But they are, I think you don't need to know a lot about them to know that they're really cool and interesting, beautiful, and obviously in a desert environment, they're really important for ecosystems, for organisms, for all kinds of stuff. So just really quickly, kind of what they are, is it's a place where you have water coming up from underground, and it usually has something to do with the underlying geology, where you have like a hard layer, a sort of a difficult to penetrate layer, and it's coming out at certain places. Sometimes there's pressure that can push them up, right, like that. But a really common one is just when this more impervious layer reaches the ground, and then so water that had been kind of capped off right here, as it's flowing, it'll go over that. It'll go over that way. So all kinds of stuff that's out of my depth, frankly, out of my expertise, but pretty cool stuff. What is a little closer to my expertise is, since I have a background in ecology, is that they provide a whole host of different ecosystems, kind of their sustenance. There are a lot of groundwater dependent ecosystems in Nevada in ways that even I was surprised at how big of a deal these are. So this series of slides is from my colleague Laurel Saito at Nevada Nature Conservancy. And just some fun facts. We have a bunch of endemic species that are basically found nowhere else. Many of them are associated with groundwater dependent ecosystems. A couple of famous ones, desert pupfish, right? Yeah. If you ever get a chance to go down south towards Beatty, places like that, maybe on the California side, Tacoma, Shoshone, there's some really cool places you can see some desert hot springs. Just gorgeous, gorgeous environments. Really fascinating. Yeah, we have over 25,000 known springs in Nevada. That I have a hard time believing that, but that's wild. A lot of our meadows are supported by springs, forest ecosystems. So it's really important for wildlife, for a lot of the vegetation and ecosystems in the state. So pretty cool stuff. And then, I wish it wasn't so, but whenever you talk about something cool, you gotta say there's always a but, right? It's like, something bummer. There's a bummer going on too. There are definitely some stressors going on with these. We'll talk about some of these, but a lot of these are, at some amount of risk due to, maybe drying out or things that are going on outside of them. So I'll talk a little bit more about these in a moment. Oh, that moment has arrived. So one of them is a pretty obvious thing. It's like, well, if you've got groundwater dependent ecosystems and then you're pumping the groundwater for some purpose, whether to supply a city or to do these like center pivot irrigation things, there's a cost to that, right? That water is coming from someplace. And so this is a really interesting image from Justin Huntington, who's at the Desert Research Institute, and he uses remote sensing, he and his team use remote sensing to try to actually measure how much evapotranspiration, the rate of water evaporation on the ground surface. So he can sleuth out and figure out. They've been able to track, in 2002, they put in this irrigation system, and this is showing the vegetation vigor in this point, right? And then once they started irrigating it, the vegetation vigor went way up, right? And this point here, on the other hand, was a naturally occurring spring, which previously had nice vegetation, and then once they started pumping that groundwater and putting it over there, it deprived it from this place here. So it's the story of humanity, right? We make choices, and I think my philosophy is that, we just have to be as honest as we can about it and try to measure things and know what the consequences are. But here's an example of a consequence of that choice. Another thing going on is our snowpack has been seeing a pretty serious decline in the last decades. We have a warming trend going on that I think everyone's heard about. But what I think has gotten less attention, even though we may see in the coming decades, we may see even an increase in precipitation. That might surprise some of you. Or we may see a bit of a decrease, but I think let's assume it's neutral or slightly increasing. Even if that's the case, the fact that the air temperature is going up, there's a strong relationship between how thirsty that air is and the temperature. So the same amount of precipitation isn't going to go as far if you have a thirstier atmosphere. So because of that, that's one of the reasons that, and also the temperature and the way the snow is falling, the dust and all that stuff, our snowpacks are going down, and that's going to have an effect on how much makes it into the groundwater system and into runoff. So this is evaporative demand, is the fancy word for how thirsty the atmosphere is. And it's just showing that we're in for, my colleague, actually my predecessor is an author on one of these reports, the National Climate Assessment, showing that we have, Dr. Steph McAfee, that we have 10 or 20% increase in how much evaporative demand we're going to have. And there's some elements of like climate change that are a little bit uncertain. That's one that's probably one of the least uncertain. That's one that's pretty clear. We've already seen earlier springs, and we can expect to see some more, just showing shift in the day of year of the timing of the spring. So shifting those springs earlier. And the translation to different amounts of snow. And these just show at different times of the century. So this is kind of by century's end. If you want to be more pessimistic, this is probably too pessimistic, okay? This is with a lot of climate change. This is probably more realistic. But even there, we're looking at about 10 or 15% less snowfall. And there's other fun stuff going on. We got horses, we got cows. Grazing and how we manage that. There's some really interesting things. There's a group, have you ever heard of a group called Roger? Roger, they're, I don't remember what they stand for, but they're a group of ranchers that's looking at trying to look at their practices with the aid of science to try to come up with the ones that make the most sense from a kind of a long-term sustainability standpoint, managing the lands where they're grazing. So grazing isn't all bad. It's just the poorly managed stuff can be a problem, or the unmanaged stuff. We got exotic species in here, and there's also urbanization and diversion of water. So a lot of things that could happen to our springs. All right, I'm at time. But kind of my philosophy, I always like to end with just some like 40,000 foot bigger thoughts about what it means and what we can do. I believe that monitoring is really important. You can't manage what you're not measuring. You can't manage it without measuring it. So monitoring is a big part of the problem. We have to keep our eyes on what's going on. And then understanding the processes, basically the science, is kind of the next step for me. Increasing awareness and understanding of the processes involved and how things are linked. And then stuff like this. I love talking to the public. I love talking to people. I learn from these things as much as I teach, I think. And also a chance to talk to decision makers so folks have a sense of what's going on. And then, let's find what actions and what management strategies, groups like Roger, that we can do. Maybe there's ways we can minimize dust that gets dust events by figuring out maybe where we need to, maybe it's irrigation in some of those spots, or a couple of weeks where we don't have OHVs running around at a certain place or something like that. There might be some choices we can make to help protect our natural heritage and resources. That's my philosophy. I'd love to hear any questions or comments if there's still time. Yeah.
Excuse me. On your previous slide, you talked about the invasive species. Is that just a matter of plants taking up residence at springs and using up the water through evapotranspiration?
Right. Yeah. So it could be plants, but that's definitely part of it. I mean, everything, even upstream. Like I don't know exactly how it works, but I'm sure that all the cheatgrass in some of those slopes is going to change the runoff characteristics a little bit, change the water quality. But there's also stuff like
power plants.
Yeah.
Oh, okay. Yeah. Elaborate. Tell us more. Power plants.
They're drying up a lot of Dixie Valley.
Yep.
Power plant.
Okay. Yeah. The geothermal specifically. Yeah. Okay. Yeah. That's another use.
Are they learning from their mistakes as far as they're finding out that they're drawing the water out, like they were drawing the water out in Dixie Valley, and just letting it flow instead of re-entering it back into the system? Are there people out there that are doing the regulations to make sure they're doing that, or are they just still doing a blind eye to it?
Yeah, that's a really good question. Are the companies that are doing those things, are they managing a way to return it and minimize the impact, or are they just kind of taking the easiest way out? I don't know the answer, and I don't know how well regulated they are. I suspect that there's, people and companies tend to do as little as possible. That's just sort of human nature. When there's dollars and cents at stake, that's what they're typically going to do. So I guess someone needs to monitor it, and yeah, I don't know. Mm-hmm.
Is there a noticeable change in land subsidence with the reduction of water in the aquifers?
Oh yeah, so question on land subsidence and water pumping. So I'm sure that happens in parts of Nevada where it's really happening famously, as the Central Valley of California, where it's like a matter of feet. Some of these places have dropped feet because so much water has been pumped out of the ground. And what I think is interesting is that there's actually satellite missions that go and measure the gravitational field. They have two sensors, and by how much each of them are moving relative to each other, they can detect how much gravitational pull there is. And the thing that really drives that, the thing that causes it to change, is the water level underground. So they can actually measure water level from satellites based on the gravitational field. And they've measured big drops in that. I don't know specific examples in Nevada that are doing that, but I'm sure there's spots. Yeah, that's an interesting question too. Mm-hmm.
I have a simple question. Why is it so windy in the spring?
Oh yeah, it is windy. I think that part of it might have to do with the positioning of the jet. We have a big contrast between high pressure and low pressure. the steeper the contrast is, the steeper the slope, the faster those winds are going to go. And then we have additional factors with, we have mountain valley winds, we have winds getting channeled through narrow valleys. I think a lot of factors kind of come together to make Nevada a pretty windy place. Although I think not as windy as Wyoming, it turns out. But plenty windy. Yeah?
So if the more rain is falling instead of snow, and it's melting sooner, then we'll have more water coming off the mountains, like in the winter and early spring, before a lot of farmers are using it. So that means Lawton Reservoir will fill up more consistently?
Yeah, that's an interesting question. I mean, those are the kinds of questions that we ask. Those are questions that I think some of my colleagues could answer better than I can. I mean, I know that one thing I'm pretty confident in is that in many systems in the West, we don't have the reservoir capacity to capture any water at the different times. I mean, there are cases where we do, but overall, it doesn't balance out the additional capture from earlier in the season. And then you get later in the season, you get earlier runoff peaks, but it also slows down earlier too. So yeah, I don't know what the expectations are for places like the Lawton Reservoir.
So with the slide showing that we're having an earlier spring and plants and animals are reacting to the warmer earlier in the season, I don't know if I've ever heard what happens on the other end. Are we having a longer summer? Is fall showing up sooner? Is all the seasons just getting...
Yeah, I don't know the exact answer other than to say that these things are not as symmetric as you might expect. Like ice on, ice off dates, I can't remember which way it works. I think it's ice on pretty similar, but ice off much earlier. Something like that in the wintertime. Where I grew up is on lakes. Like ice fishing is a big deal. So people have been monitoring that for over 100 years. But in terms of spring, I think it's a little bit more volatile in the spring. And that's one of the things I didn't get a chance to talk about is, has anyone heard of a false spring? Use your imagination what that might be like. Right, yeah, we get these situations where the plants are like, all right, it's party time, and then another freeze comes in, and that can really wreak havoc on plants and also on birds and migratory timings. There's all kinds of, I think I saw a bird shirt. I did see a bird shirt someplace. Someone had a bird shirt on, bird watching shirt. And yeah, definitely timing of spring and migratory birds, there's all kinds of interesting questions about that. Yes. Great. Well, I enjoyed speaking with you and look forward to chatting a little bit over some snacks. Thank you for your time.